Hi, this is Jeff Langer. In this video, I'll be using TDD Paint-by-Numbers, where the tests are already written for you. This is a technique I learned from James Grading, and it's a great way to start up on test-driven development. In this exercise, I'll use the tests that are already written to incrementally test drive a name normalizer. If you want to try this exercise yourself, you can clone the repo from my GitHub page. I'll head over there now. My homepage is at jlanger, J-L-A-N-G-R. This exercise is in the repository name normalizer. I'll click the clone link, copy that, drop over to a command line and do a clone. And then I'll tab over to IntelliJ IDEA where I will import the project. Name normalizer, in the repository you'll find half a dozen or more different language implementations of this. We'll be doing Java. If I click on OK, this is a Gradle project and I can accept the defaults on the next couple dialogues. This does have a Gradle wrapper installed with it, so you should be good to go even if you're not using Gradle currently. Within the project, I have source main Java author name normalizer. This is the production class that I'll be test driving. I also have a set of tests in source test Java under the util package. Name of the class is an author name normalizer. This is written using JUnit 5. If you need to downgrade to JUnit 4.x, it wouldn't be too much effort to do so. The test and author name normalizer are all disabled, so the job will be, let's enable these one by deleting that add disabled annotation. And then we'll make sure we follow the TDD cycle to get each of these tests to pass in turn. First things first, I need to run the test. I run all the tests under test Java and they all pass as probably expected. The tests are all marked with an @disabled annotation. My job in TDD Paint-by-Numbers is to get rid of these one by one starting at the top. I delete the first annotation, rerun the test and make sure that they fail. So at this point, let's take a look at the test and see what it's saying. Test name is returns empty string when empty. It takes an author name normalizer instance and calls the normalize method on it with the empty string, and then asserts that it's equal to, the results of normalize is equal to the empty string also. If I click on the failure, I see the stack trace and the runtime exception coming out of this. Looks like it's getting thrown by the normalize method. So I click on that in the stack walkback, and I see that indeed the normalize method does nothing other than throw an exception. It looks like this is stub code. So I want to focus on both the test and production code. Let me clean up a few things. I'll hide the project view and split things so that both production code and test are visible left to right. I'll also maximize the window so we can see everything a little more easily. My job when doing test-driven development is to make my test pass in the simplest fashion as possible. So for now I have one test that specifies by example one behavior, which is return an empty string when past the empty string. Making this pass in a simple fashion is as easy as returning a hard-coded empty string. And sure enough, that passes. Ship it! Well, I can't ship it. I have to follow the TDD cycle, which is this whole write a test or get a test failing, then get it to pass, then clean it up a bit. We call this red-green-refactor. You always have to make sure you do some cleanup in the refactoring step if necessary. It's often easy to introduce new little bits of code that demand some level of cleanup. In this case, I've got a little bit of code here that's not very self-explanatory. The variable name for the parameter is s. That doesn't tell me what we're dealing with. I think it's just a name. I'll make that small change, rerun my test, and make sure they pass. Now I can ship this stuff. One thought about, so the hard-coded stuff can often bother folks. One way I think about test-driven development is to help me incrementally grow code. And with that in mind, I view the set of tests that are currently running as a set of assumptions about what the system does currently. Since we have only one test, it says return an empty string when passed an empty string. I can kind of assume that there are no other behaviors that pass in anything but an empty string. So I don't have to worry about those at this moment. I know I'm going to need to write more tests to flesh out more interesting behavior, but right now all I need to worry about is that empty string, which means I don't need any sort of an if condition here. I can simply return the empty string. With the first test passing, I can move on to the second. Line 21 has an @disabled annotation. I'll delete that. Run the test and make sure they fail. While the tests are running, I'll take a look. This says return single word name. If Plato's passed in, Plato comes out. The name normalizer currently is hard-coded to return an empty string. I think this is as simple as changing that to return the name that's passed in, which will also return an empty string if the empty string is passed back. And sure enough, that passes the test. I'll move on to the next test. I have an @disabled annotation further down on line 27 in this case. So I'll delete that and rerun my test and start taking a look at what this test is specifying. Assert that name normalizer.normalize Haruki Murakami is equal to Murakami, comma, space Haruki. So swapping last for first, presumably so it can alphabetize things. We have a failure. And one thought about getting this to work is the general algorithm would be split the name into parts on the space character and then just swap the parts if there's more than one part. So name.split on space. And we'll introduce a variable called parts here. Oh, space has got to be a string, not a single character. If I only have one part, in other words, parts.length is 1, we want to return the name. Otherwise, we want to return, let's see, I can do this with, we'll do it with simple concatenation. Part sub 1 plus, well, that needs to be a string, plus parts sub 0. I think that's the right logic. I'll run the tests and make sure they pass. So I have an implementation, but I also have an opportunity to do some bit of cleanup during the refactor step of TDD. This code isn't bad by any means, but it's also not very intention revealing. The question becomes, how quickly could someone read this and understand exactly what was going on well enough so that they could change it? It might be trivial, but whoever picks this code up has to spend just a little bit of time to kind of piece things together. For example, what's the meaning of part sub 1? Well, if you understand the domain well enough, you probably figured out that that represents the last name. What does it mean for parts.length to be 1? So there's a few elements in here that are not directly intention revealing. These little pieces of nebulous code add up quickly. It's fairly easy to clean them up and impart a little bit more readability into the code. It costs almost nothing to do so. Part sub 1, as mentioned, doesn't declare very directly. So maybe I want to introduce a variable or a method. And I think I'll go with method because what it helps do is keep the vertical length of normalized down to a minimum. Let's see. I don't want to fold parameters. I'll give it a name of last name and press enter. So what that starts to do is lend immediate readability to what we're actually outputting in the formatted string that gets returned from normalize. I'll do the same for part sub 0 and introduce a method called first name. Oh, nope, I didn't want to do it that way. I don't want to fold parameters, so let's undo that. So turn off folding. Call this first name. And just for grins, I'll make sure that this runs the test. Even though these are automated refactorings, it's still a habitual thing for me to make sure that I get the feedback that I haven't inadvertently broken something else. Highly unlikely, but I love the feedback. I also look at this conditional. Often to me, the conditionals, which are telling you what places to go based off of something interesting about information coming in or state data, those are often opportunities to very clearly help us understand what the algorithm's all about. So I will often extract these to their own separate method. If part sub dot length is 1, well, we have what's known as a mononym, or a single word name. I'll extract that as a method and rerun my test. There's a little bit more opportunity for cleanup. Last name, part sub 0 is probably obvious, but part sub 1, I suspect that we could make this a little clearer by saying that it's really the part at the very end of the parts array. So on line 20, I'll change this to parts.length -1, a little bit of generalization, and make sure that that still passes my test. Okay. What I end up with after refactoring the normalized method is code that's a little more sensible, and more importantly, if someone has to pick this up and understand it well enough to be able to make a change, it's very clear what this algorithm is all about. I have a name coming in, I split it into parts based off the space. If I have a mononym, then I simply return the name that was passed in. Otherwise, I return this formatted string that says, get the last name from the parts, follow it with a comma, get the first name from the parts. I've built 3 different helper methods, each one a single line long, and these helper methods are all about abstracting out implementation details. We're separating interface from implementation, if you will. So I have isMononym, which just says, do we have one part? I have a method that says, give me the first name given the parts, which returns the first element in the array. That's an implementation detail. And I have the last name. If I need to change any one of these, they're isolated, they're easy to understand, but I don't have to read that detail if I don't want to. Moving on to the next test. Trims leading and trailing white space. Assert that if I normalize big boy with a bunch of spaces on either side of it, I end up with the trimmed string boy comma big. The test fails. I believe this is as simple as doing a name.trim.split. And run the test. Name.trim.split isn't bad, but it is starting to get a little mouthy, and just because I'm getting a little compulsive about this the more that I write code, I'll actually extract that. Where this all heads is that all the implementation details start to disappear. How we get a string array of parts varies in the method called parts. So everything that's left in the normalized method ends up being very declarative. The things that are likely to change the implementation details are buried in a bunch of smaller helper methods. Next test. Initialize this middle name. Assert that normalize of Henry David Thoreau equals Thoreau, comma, space Henry D, period. So it looks like we just want to initialize all of the middle names. Since I've gone down this route of using a fairly declarative normalized method, crafting a fairly declarative normalized method, I want to stick to this notion. Rather than build some implementation detail-worthy code in Normalize, I'll start my declaration from Normalize itself and just say I want a middle initial given the parts. I'll let my IDE build this and then figure out what does this really mean. I mentioned assumptions earlier. Right now I have the assumption that I either have one name, two names, or three names. For this test I have three names, but I need to make sure that if parts comes in, it represents only two or one names, that we just return nothing for the middle initial. So if parts.length is less than or equal to 2, return an empty middle initial. Otherwise, I want to return the initial of part sub 1. Now what does it mean to return the initial? I'll build a method for that. We'll give this a slightly better argument name of name and return name dot char at 0. Plus we'll also need a period. Rerun the test and make sure that works. Meanwhile, while it's also thinking hard, I will split my formatting string so that I can clearly see what this normalized method's returning. No, that failed. Okay. Expected throw Henry D, but with a space, but there's no space in the actual output between the Henry and the D. It's easy enough to rectify. I should probably change this to use string.format at some point in time, but for now this is sufficient. I'll get my algorithm all done and then maybe consider cleaning up to more better Java idioms. Alright, that passes. Is there any code that can be cleaned up in here? In middle initial, I have, again, a conditional that has a bit of implementation detail but doesn't tell me the why, and I always find this a little frustrating, particularly when picking up more interesting code than this. I'll extract parts.length is less than or equal to 2 to something that basically says, well, we have no middle name in the parts, in which case we want to return an empty string. Earlier I was a little compulsive about extracting things out into little helper methods, last name, middle initial, first name, and so on. I want to continue in that vein and just see where this takes me. So on line 16 I have part sub 1. I'll extract that into its own method. I'll call that middle name given parts. And notice that middle initial it's still pretty small and trivial, but it does have a few pieces of logic in it. So the more I can basically split things between some overriding algorithm or policy and the implementation details, the better off I'll be. The next test does not initialize one-letter middle name. Assert that normalize of Harry S. Truman is Truman, comma, Harry S. Poor Harry had no middle name more than one letter. S was his middle name, and therefore we don't want to put a period after that. The nice thing about having isolated code into these little helper methods is it often makes your changes also isolate to one place in the code. In this case, I have an initial method. Within here I can add a simple guard clause that says if name.length is only equal to 1, return the name itself. Passing test. Moving on to the next test. initializes each of multiple middle names. We have a person, Julia, with two middle names, Scarlett and Elizabeth, and it looks like that should distill down to Julia S.E. I'll disable that, or undisable that, and run the test, which does fail. Where I probably want to start with this is a little bit of renaming. The existing code dealt with a single middle initial given the parts on line 10. I want to change that to reflect the fact that we're dealing with multiple middle initials. We'll call the method middle initials, plural. And that also means I want to deal with multiple middle names. I'll focus first on the middle names, and then also on line 16 I'll need to deal with the fact that we have multiple initials. We'll come back to that. Middle names, I can actually return, I'll take the stream from the parts, and then from that stream I want to skip the first element because that represents the first name. Then I want to take up until the limit of basically the total number of parts minus 2, because I don't need the first name, I don't need the last name. So limit of parts.length minus 2. That's my return value, and notice I'm getting compile issues. Instead of returning a string, I want it to return a stream. And what that means is I'll have to change whatever that gets passed to. I have initial as a method. I kind of like what that does. I'll pull that up so we can see it. Initial of the name just works with a singular name. What I want is a new method, maybe called initials, that takes a stream of the middle names. So create that as a method. It returns a string. I'll give the parameter a better name, such as names. And here I will want to return names.map to this : initial, that initial method we just saw. And then finally I want to collect all that using joining collector. So collectors.joining on the space character. Alright, and that represents initials. So let's see if that actually works. I'll rerun my test. And that all passes. One of the things I love about the TDD cycle is my ability to change implementation when I get to the refactoring step. Right now I have a middle initials method that uses Java 8 streams, and that's okay. But maybe I can't use Java 8, maybe I don't like it, maybe I find there's performance issues, maybe I want to go with classic Java because maybe I find it reads better. The beauty of TDD is it lets me play with these algorithms or implementation details. I can change them all I want. The beauty of splitting things out between overall algorithm and these helper things is I can often make these changes in isolation. Granted, right now the initials method's very tightly coupled with middle names since one passes a stream to the other. But I've got a pretty reasonable chance of isolating my changes and not having to make scattershot changes throughout the body of a longer method or through a larger number of methods. So the old school mentality was if it ain't broke, don't fix it. And what I think about that TDD does most for me is it lets me discard that. This ain't broke, don't fix it thing is a recipe for letting our code bases slowly but surely get worse over time. With TDD, at least I have a fighting chance of sustaining my system over longer periods of time because I can keep the code clean as I go. Time to move on to the next test. Append suffixes to end. If I normalize Martin Luther King, Jr., I get King, Martinell, Jr. So it looks like it just takes the suffix and then tacks it onto the end again after the rest of the name is normalized. Looking at the normalized method, this reads pretty darn well, and I'd like to keep it that way for this notion of the suffix. But it sounds a little like I need to get rid of the suffix from the name, do the rest of the normalization, and then tack it back on again, which almost suggests that I need some sort of a temporary to represent that suffix, or maybe not. What if instead, let's see, I have parts of name. What if in this call to parts, instead I pass a suffixless name, whatever that happens to mean, and then in the formatted output, I give it the suffix of the name. Let's do Shift F10, Alt Enter, create method suffix. Basically, I need to split on the comma or find the comma one way or another. I'll do the string split just to be consistent with coding the rest of the author name normalizer. So name.split on comma. That's going to give me string array name and suffix. If name and suffix dot. Now let's see if I don't have a suffix. So if my length is equal to 1, I want to return empty string. Otherwise, I want to return name and suffix sub 0. So I think that is the suffix method. Let's go to 9. I'll create a suffixless method, and that's going to be much the same. Oh, that was wrong. 25 should be, suffix is the second element, or rather sub 1. For suffixless, I should be able to do much the same logic, except if I don't have a suffix, then I simply return name, otherwise I return sub 0. Certainly a case to be made that this is kind of a wasteful approach since it requires doing the string split in a couple places. Let's worry about that in a bit and see what the problem is. All right, right off the bat, looks like it needs the comma to go on the suffix. I'll run that. Make sure that works. No, still not working. I have too many spaces. What I'm really liking about things is that my normalize method is still about as small as one could expect. It simply declares things. It doesn't go into specifics of how it gets them. I think this is an ideal design coming into a method with a fairly interesting algorithm. Looks like I'm down to the last test. Throws when name contains 2 commas. Fairly straightforward, but it is an interesting test in that it asserts that an exception gets thrown on some code. So it's basically covering a negative case. With TDD, these are just part of how you test drive. It's just yet another test that your job is to get to fail first and then get to pass. It contrasts to typical development where developers are pretty good about getting their happy path code working. Then they come along a little later and sneak in some exceptions where they think there could be some that are thrown. This test fails. I'll implement it in a, once again, declarative manner from the normalize method. Throw when contains too many commas, name. Create that as a separate method. If, let's see, how do we do this in Java? Name, I know I can get chars. I can filter the characters where each character is a comma. And then finally, I can take the count. And if, now it's starting to scroll here, let me just decrease that a little bit. If the count is greater than 1, I want to throw a new illegal argument exception. and see if that passes. Every once in a while I'll write code that I'm happy enough with. I take a look at throw when name contains too many commas and consider, is this good enough? I think the name's fine. I think the code in it's fine. It's an implementation detail of 2 lines, so I don't believe I need to introduce anything to clarify it. Every once in a while this will happen. There's really not much to clean up on the code I just wrote, but it also represents an opportunity. Maybe my code's fine. Perhaps I should take a look at some other things. Sometimes I'll look around the periphery of the code I just wrote and see if there's any opportunities for cleanup on that. Other times I'll take a look at the tests and see if I can do something to improve those. Or even see if perhaps I've missed something. I'll click back on an author name normalizer and take a look at all of the test method names. I did a Command F12 in IntelliJ IDEA. One of the cool things about doing this is I get a holistic picture of what an author name normalizer does as a whole. What are its behaviors? Set of test names should tell a story about all these things that it's capable of doing. I'll often bring this list up and just use it as a trigger to say, am I missing something? Or even just to take a look at the set of test names as a whole to make sure that they are consistent with each other. In this case, something did trigger in my head. It came from looking at the code, though. In the normalize method, after removing the suffix, if I have a mononym, then I return the name passed in on line 12. But it's certainly possible for a mononym to have a suffix. So imagine Plato Jr. or Madonna Sr. or something of that sort. I think that's a problem and it might not work. Whenever I think something's a problem, I always write a test and see if that test fails. At the very bottom then I'll type in test and I'll call this for the time being retain suffix for mononym. Spell mononym right. The assertion is going to be much the same as the one for Martin Luther King Jr., but I'll just go ahead and type it out. Assert that normalizer.normalize. And if I normalize Madonna Jr., then it is equal to Madonna, comma, Jr. Alright, format that, and let's see if that fails. No, that does not fail. It's a probe, and sometimes I'll have this little concern to think, is there a problem? And sometimes there is, sometimes there's not. If there's no problem, then I have the question of, do I keep this test around for documentation purpose, or do I discard it? In this case, I'll just keep it around for now. I want to explore something else, the whole white space thing. What happens if I have white space around a name with a suffix? So let's take this very same test, and this time I'll cheat and do a little bit of copy-paste. I don't know what the name of this is just yet, so I'll call it X. But the question is, what if I have white space around Madonna Jr.? Does it normalize to a name with that trimmed correctly? And I think looking at the logic in the normalize method, this is going to be a problem. Yeah. So it's not trimming things. I think part of the problem is that I buried my trim somewhere in one of those helper methods. I think it was in the parts method. Let me control B into that, and sure enough, there's the trim. Let's see. Let's delete it from here. And then coming back into the normalize method. Let's see. I need to trim before I get rid of the suffix, or do I? Yes, I do. So I need to do a name.trim here. But I would also have to do a name.trim here. And once more, I believe a name dot, well, you know what, let's try it there. I think I need a name.trim in all three places, so this is looking unfortunate that I'm doing that all over. That works. Actually, I only need it in the 2 places. Well, maybe the best thing is extract this to a variable and call this, replace all 2 occurrences. I will call this trimmed name. So I think that's reasonable. Not thrilled about the extra local variable in here, but then again, it's better than having the duplicate trims all over the place. That just is not so much that I care about the redundancy in trimming from a performance stance, but the fact that it's kind of confusing about what we're dealing with. So I think doing it once and for all is perhaps the best solution for this. My probe failed. I got it to pass. My very last action is a little bit of cleanup. In this case, I'd come up with a little placeholder name of X for this test. So I want to give this a more appropriate name and then keep it in my canon of tests. Maybe this is trims white space. A name normalizer trims white space for mononym. And just for grins, I'll run the test one last time, and I think I'll be happy with things. This is test-driven development. The paint-by-numbers meant that someone else wrote the test for you, but it follows the same cycle as if you were deriving these tests on your own. In terms of the solution I have, first, from this test side, I love the way that I can do a Command F12 in IDEA, for example, and show a list of all these test names, and it tells me a whole story about what the name normalizer does. If I need to understand any one of these in detail, what does it mean to swap first and last names, I can select a test and look at the example that it contains. In this case, I see very clearly the inputs to normalize and what we expect in terms of an output. From the production side of the fence, I've harped on this quite a bit, but I love the way that the normalize method is highly declarative. It establishes and declares a policy or algorithm for what it means to normalize a name. All the details are located within tiny little helper methods. If I scroll through the list of all these, I think the longest one is a 4-line method in the suffix and suffix lists, different methods. Everything else is very succinct 1, 2, 3-line methods. Those are easy to understand. It's also easy to look at these and know whether or not they do what the intent is declared by the method. Generally, I don't need to look at these implementation details unless I'm getting into changing the mechanics of one of them. Overall, then, I'm pretty happy with the implementation for the name normalizer. I think it would hold up well to any additional features that someone required, so maybe that's an exercise that you could give a go. Add a few tests about some other interesting things. What happens if we have multiple suffixes, for example? What happens if we have things up front like Mr. and Mrs. and so on. This ability to incorporate new requirements incrementally, I think, is one of the biggest strengths of test-driven development. We know that we can keep the code clean as we go because we have the test, and as such, it makes it a lot easier to accommodate new features as they come along down the road. Thanks for watching. This has been TDD Paint by Numbers. Look for more sessions in the near future.